Students, let's discuss exercise 12.2 sixth sum. A chord of a circle of radius 15 centimeter subtends an angle of 60 degree at the center. Find the areas of the corresponding minor and major segments of the circle. Okay, here the subtended angle is 60 degree. Here we need to find out the major segment and minor segment. So the radius of circle is 15 centimeter. So here first we need to find out the sector. Sector, the area of sector OPRQ. Thereafter we need to find out the area of the circle. Then subtract the area of circle from the area of sector OPRQ. Then we can find out the minor sector. Then how to find out the major sector? That is very easy. First to find out the area of whole circle, then subtract the area of this minor sector. Then you will be get the area of major sector. So first we need to find out the area of sector. So area of sector OPRQ. OPRQ equal to theta by 360 into pi r square. So 60 divided by 360 into pi. R value is 15. So 15 degree. So the area of sector is 117.75 centimeter square. Next we need to find out the area of the circle. So the circle area of triangle OPQ. So see this is isosceles triangle. So this angle, okay. So the common angle for the equal side is 60 degree. So this angle 60 degree, then the sum of remaining two angles is 120 degree. So this is isosceles triangle. Okay, so yes, that means these two angles are equal. So the angles are 60 degree, 60 degree. Here all the angles are equal. So this is what kind of triangle? So this is equilateral triangle. So you know that how to find out the area of equilateral triangle. So area of equilateral triangle, the formula is square root of 3 by 4 into side square. Then side we know that 15. Substitute, then we'll be get 225 square root of 3 divided by 4 centimeter square. So 56.25 square root of 3, the value approximately 1.732 something. So 97.3125 centimeter square is approximate value for the area of triangle OPQ. Then the area of segment PRQ equal to area of sector minus area of the triangle. So then will we get 20.4375 centimeters square. Next we need to find out the area of major segment of the circle. So major segment of the circle is area of circle minus area of the minor segment. Minor segment we found. Subtract these two. So if you subtract it, we'll be get the answer is 686.0625 centimeter square, the area of the major segment. And the area of minor segment is 20.4375 centimeters square. Students, let's discuss exercise 12.2 seventh sum. A chord of a circle of radius 12 centimeter subtends an angle of 120 degree at the center. Find the area of corresponding segments of the circle. Use pi 3.14 and square root of 3 is 1.73. So the angle SOT is subtended to the chord ST. Here we need to find out the segment SUT. So that means first we need to find out the area of sector SOTU. Thereafter we need to find out the area of this triangle. Then subtract the area of triangle from the area of sector SOTU. Okay. So first we need to find out the area of this triangle. Here the angle is 120 degree and we know the side is 12 centimeter 12 centimeter. By using this we cannot find out the area of triangle. Okay. If you want to find out the triangle, so first we know that all the sides, okay, the length of all the sides. But here we know that only two sides. The third sides we don't know. Okay, so for that purpose, here I am going to draw one perpendicular line OV perpendicular to ST. So this OV is dividing this chord into two equal halves. Okay, so already we studied this concept in ninth standard. So the perpendicular line, okay, it bisects the chord into two equal halves. Then will we get two right angled triangle. Okay, in the right angle triangle, if we know the base and height, we can find out the area. But here we don't know the base and height, but we know that SV equal to VT. Okay, these two are equal. If we found SV, that is equal to VT. Okay, so first we need to find out SV and OV. To find SV and OV, here we are using the trigonometric ratio. Okay, so briefly discuss about this one while discussing trigonometry. Okay, so here the angle is 60 degree. At the same time, we know that the longest side is hypotenuse. We know the hypotenuse and one angle. So first I am going to find out the side OV. OV is adjacent side and SV is opposite, which is opposite to the angle, that is opposite side. Okay, so SV is opposite side and OV is adjacent side. So first I am going to find out adjacent side. At the same time we know the hypotenuse. So adjacent and hypotenuse. Okay, that is under which one? That is cos theta. Okay, so cos theta equal to adjacent divided by hypotenuse. So cos 60 degree equal to adjacent divided by hypotenuse. So cos 60 degree, the value is 1 by 2. Students, now you try to understand this one. Okay, so briefly we will discuss while taking the trigonometry. So cos 60 degree, the angle cos 60 degree is 1 by 2. Then OVE divided by OAS is 12. So if we transpose to right hand side, OV will be 6 centimeter. Okay, so OV equal to 6 centimeter. Next we need to find out SV. For SV, here we know the hypotenuse and this is opposite side. So hypotenuse and opposite, that is sine theta. So see this sine theta equal to opposite by hypotenuse. So SV by SO. So sine 60, the value is root 3 divided by 2. So root 3 divided by 2. So that means SV equal to 12 transpose to right hand side will be get SV equal to 6 square root of 3 centimeter. So SV equal to 6 square root of 3 centimeter. Then what about ST? The total length of the chord is 12 square root of 3 centimeter because these two are equal, so multiplied by 2. So we found the base value of the triangle and height of the triangle. Okay, so use the formula of into base into height. So base is ST and height is OV. So base is 12 square root of 3 into height is 6. Then we'll be simplify. Then we'll be get the answer is 62.28 centimeter square. We found the area of the triangle. Next, area of the sector OSUT. So theta by 360 into pi r square. So the answer is 150.72 centimeter square. So area of the sector. So area of segment SUT equal to area of sector OSUT minus area of triangle OST. Okay. So the answer will be 88.44 centimeter square. The area of the segment is 88.44 centimeter square. Students, let's discuss exercise 12.2 eighth sum. A horse is tied to a peg at one corner of a square shaped grass field of side 15 meter by means of a 5 meter long rope. Find the area of that part of the field in which the horse can grass. The increase in the grassing area of the rope was 10-meter long instead of 5 meter. See the question. A horse is tied to a peg at one corner of a square shaped grass field of the side 15 meter. Okay, the side grass field 15 meter by means a 5 meter long rope. Okay, so a 5 meter long rope the horse tied. So area of that part of the field which the horse can cross. So we need to find out the field. Okay, part of the field in which horse can grass. So that means we know that this is quadrant. Okay, we can take that is quadrant of circle. So this angle is 90 degree. So angle 90 degree and the length of the rope is 5 meters. So that is radius. So we need to find out the area of this sector. Next again the rope will be increased. So how much increased? That is 10 meter. So rope is increased 10 meter. We need to find out the area of field in which the horse can grass. Okay, so there the angle is 90 degree. At the same time the length of the rope is 10 meter. Okay, so first we need to find out if the length of the rope is 5 meter, the grassing area. We need to find out the grassing area if the length of rope is 5 meter. So we know that from the figure already we discussed this is 90 degree. At the same time the length of the rope is 5 meters, so that means the radius of the circle is 5 meter. Okay, so area of sector OACB. C is length of arc. So theta by 360 into pi r square. So theta value we know that 90 by 360 and r is 5. Substitute and simplify, then we'll be get 19.625 meter square. And the next, if the rope will be increased, the length of the rope will be increased, we need to find out the grassing area. So take r as 10. So that means the area is 78.5 meter square. At the same time we need to find out that increase grassing area. So how to find out the increased grassing area? Okay, so we need to subtract 19.625 from 78.5. Okay, so actually this is the area of sector if the radius is 5 meter. Okay, this is the area of sector if the radius is 10 meter. If you subtract this, you will be get 58.875 meters square. Actually, this is increasing area. When if we extend the rope, this much area increased. Okay, students, let's discuss exercise 12.2 ninth Roman. A brooch is made with silver wire in the form of a circle with diameter 35 millimeter. The wire is also used in making 5 diameters which divide the circle into 10 equal sectors as shown in figure. Find the total length of the silver wire required. The area of each sector of the brooch. So first here we need to find out the required length of wire, silver wire. At the same time, here we need to find out the required wire for 5 diameters. Okay, so 1, 2, 3, 4, 5. Okay, for this 5 diameters we require some length of wire. Okay, so here we need to find out the total length of silver wire required for this circle and 5 diameters. Okay, for the decorating. So first we need to find out the circumference. Thereafter we need to add the length of diameters. Okay, so totally 5 lengths are there. So each diameter is 35. So 5 into 35 we need to add. So we know that the radius of the circle is 35 divided by 2 because that is diameter. So the circumference of the brooch or circle is 2 into 22 by 7 into 35 by 2, that is radius. So the circumference of this brooch is 110 millimeter. At the same time, what is the required length of wire? So the required length of wire is 110 plus 5 into 35. So 5 into 35 is 5 diameters into the length is each diameter is 35. So 5 into 35. So 175. So the length of the wire required is 285 millimeter. At the same time, we need to find out the sector of each angle. So here totally how many angles are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So totally 10 parts of circles are here. Okay, so we divided into 10 parts. That means each part contains 36-degree angle. So what is the area of each sector? So here we know the angle is 36 degree. At the same time we know the radius of the circle is 35 by 2. Okay, substitute the formula area of sector theta by 360 into pi r. Theta value is 36 degree. If we substitute, then will be get the answer is 385 divided by 4 millimeter square. So the area of sector is 385 divided by 4 millimeter square.